Welcome. My name is Martin Gysi. I'm from the network development team of Swisscom and Mr. IPv6 at that company. Swisscom is a small ISP for the world. We have about 1.5 million broadband customers, fixed line, about 6 million mobile subscribers. But we have quite an important market share in Switzerland. We have about 50% of the market for the broadband subscribers. So I'm going to talk about actual deployment experience, just two aspects of it. The first one is a rollout of our 6ID-based IPv6 solution for the wireline network, and I'll also touch a bit on IPv6 in the data center that we're rolling out as we speak, actually. So the actual rollout of 630, has been quite a success. A year ago, we were, as Leslie said, below 1%, and now we've actually made Switzerland advance to the world number one, with about 11% of users using IPv6 on a regular basis. That's taken from the Google statistics there. Here are some statistics on our deployment. IPv6 traffic is beginning to be significant, and it grows quicker than IP version 4. That's an important point. The market share, or the share of it, is growing. It's not just the traffic, but it's also the actual share of it. You see on the left-hand side, the broadband customers, we have activated IP version 6 to about 40% of our customer base. So these are all dual stacked. Out of that 1.5 million, we have 650,000 users that can use IPv6 as well as IP version 4. Of course, this is dual stacked, so we don't turn off IP version 4 as yet. If you look at the total internet traffic, this is traffic going to the internet. We have about 270 gigabit of traffic. 7% of that is IPv6 already. So that's still 93% of IP version 4, but that share is growing quickly as well. If you consider a person or a subscriber that is dual stacked, the share of IPv6 is a bit more important. We see 18% of IPv6 traffic versus 82% of IPv4 traffic, if you consider the peak average. How do we do that? We have a DHCP-based model, so we cannot just leverage PPP. Hence, we had to stick to deal with that DHCP model. Our access network was not capable of doing dual stack IPv6, so 6RD was a perfect solution for us. The actual experience is very good. It scales. It actually scales better than dual stack. We see that once you turn on dual stack on a BNG, the number of subscribers that BNG supports will usually have. That's what we see from many vendors, that they support half as many dual stack customers than IPv4 only. So when you compare adding more BNGs, buying more BNGs, or scaling your 6RD border relay, scaling 6RD border relay is much cheaper. So that's why I say it actually scales better than dual stack. So in the short term, we'll just increase the performance of our 6RD border relay. Right now we have a redundant pair of Cisco CRS with Blade in it. That's just enough for the traffic that we have right now, but we'll have to keep on adding blades or look for a more scalable solution. In the future, I believe that staying single stack in the network is the way to go. There are a number of options of how to do that. I think the most promising one right now is the one called MAP, which encapsulates IPv4 over an IPv6 only network. There are another number of proposals that are feasible as well. The time which point in time do we switch over from being IPv4 only to IPv6 only? Of course, transporting the other protocol through the network. That's probably when we reach 50% of IPv6 traffic. We'll see. That's not, cannot predict that yet. If you look at the traffic pattern, at the top you see our total traffic, about 260 gig per second peak. That's going towards the internet. And compare that to the actual IPv6 traffic, you see that it looks pretty similar. So this is probably due to the fact that most traffic comes from just a few sources. Google, Facebook, YouTube, Wikipedia, Yahoo. These are top 1 to 6 for Switzerland in the Alexa ranking for Switzerland, and they're all dual stacked. So that's where most of the traffic comes from. Actually, 1 year ago, we had 560 megabits of IPv6 traffic peak. Today, we're at 18 gig peak, and we're expecting 60 to 80 by the end of next year. So that's our next scaling goal. Swisscom, well, it used to be number 9. I have to update my slides. Right now we're at position 12. That's not a big deal. The interesting number is that the website worldIPv6launch.org measures about 18% or 19% of our users using IPv6. Now we have activated it for 40%, so it seems like only half of those users are actually use IPv6. Now why might that be? We can only guess. One guess might be that they have old operating systems, Windows XP, where IPv6 is not activated by default. It might be due to some happy eyeballs algorithms where the operating system actually prefers IP version 4 over IP version 6. Yeah. But I've heard from other operators that this is about their ratio that they see as well. So about half of the customers that are activated for IPv6 actually use it. Which, on the other hand, also means that the share of IPv6 for a customer that is activated and is actually using IPv6 is higher than the 18% that I've reported on the previous slide. So it might actually be as high as 40%. And we have not even yet activated Akamai caches for IPv6 yet in our network. So we expect that share to rise once we do that. That's how we rolled out in big chunks, actually. We started with a small-scale pilot of a few hundred users, then expanded that to about 30,000 users. Then when everything went well, a larger pilot with 100K users, 450K users, and a few weeks ago, 2 weeks ago, no, a month ago, we added yet another 100K users. Step by step, we use our TR69 infrastructure. Most of the modems or routers that our customers use are managed by us. We sell or give it for free to the customer. We have our own router that we design for the customers, and we have still some 900,000 users left. One big chunk will follow at the beginning of next year. 400K users from CP vendor Motorola will be turned on by then. And after that, IPv6 is turned on by default. And as the old CPs that are not upgradable get exchanged, the ratio of IPv6 deployment should eventually reach 100%. This probably takes another year or two until we are there. So IPv6 is part of the normal broadband internet service. We do turn it on without informing the customer. So it's just a switch in our logic somewhere, and IPv6 is turned on. This actually went very well. We did not get hardly any complaints. These are some of the issues. These are the issues that we encountered. It's very few of them. So before rollout, during the pilot, we noticed that. we noticed some missing feature. The one missing feature that we saw was that customers expected to have a firewall on the device. They were used to that because of the NAT. They used to have an IPv4, so hence we integrated a firewall. But we actually also made it in such a way that we don't interfere with applications. Well, there's two levels. There's one level that is what we call a strict mode, that is akin to the NAT way of doing it. So outbound connections are allowed, inbound connections are denied. But we also have what we call balanced mode, and there's actually an internet draft on how we do that at the IETF, which is we only block some selected ports that are known to be LAN ports, for printers or Microsoft file shares, and all the rest are basically allowed. This is, I guess, good enough to protect from most threats. And then to roll out, we had other issues that are not really related to IPv6, but held us back anyway. For example, a DSL layer driver that was not correct, so that quickly adds delay of 6 months to rolling out a new CP. One thing that we saw is also that IPv6 forwarding was implemented in CP in the CPU, not on the actual switch. So this limited the forwarding capacity. This could also be solved by another firmware upgrade. After rolling out, we saw very, very few customer complaints. Basically, the rollout went unnoticed, except for the IPv6 community, but our customers didn't see that. Even when we had, for about half a day, a misconfiguration on the border relay and IPv6 didn't work, customers didn't call because happy eyeballs managed to cover that all up. So in the meantime, we have had some reports that might be, we're not sure yet, might be reported to IPv6. Customers report that they have issues with IPv4 multicast, IPTV, or wireless LAN to Ethernet bridging, and it seems like when IPv6 is deactivated on the CP router that those issues disappear. So there's kind of weird things that we don't really know whether it has to do with IPv6 or not. So that's the status of our 630 rollout. Then quickly, the few minutes that I have left, IPv6 in a data center. We're rolling out right now. This is our legacy, what we call product IT data center. It's a legacy network, a classical 3-layer zone, entry zone, DMZ, a private core with a secure zone and a high secure zone, 3 levels of security, separated either by routers with access lists or with firewalls built on old Cisco equipment, 7500, 7300, ACE30s, 4900 checkpoint firewalls. So this is really rather old equipment. What we quickly saw is that the lower part of the network, the secure zones, these are for internal services only. So they don't have to communicate with the internet, hence the need for IPv6 is not there. So only the upper part, the entry zone where the actual internet reachable servers are positioned have to be enabled for IP version 6. That part, or the entire data center actually, is built on MPLS VPN technology. So the obvious choice to deploy IPv6 is using 6VP. What did that mean? Basically, a software upgrade on the route reflectors and on the PE routers. They were on some older iOS version that needed an upgrade. But after that, the actual configuration was straightforward. It's your basic BGP routing, VPN access lists, route maps, and so on configuration. A bit of engineering work, but that could be done and was rolled out successfully. The P router, of course, the core of the network doesn't have to be changed. That's how 6VP works. It uses the IPv4 for the signaling layer. We also had to enable IPv6 for the load balancers. We use an ACE30 there as a blade in the 6500 router. That created some issues, especially with stability. We're working on that as we speak. Some of the issues that we encountered or are encountering, one thing to consider is the routing table size. On that old hardware is somehow a bit limited. We are already at the limit with IP version 4 in some parts of that network, so we had to strictly limit IPv6 to a few selected services. We cannot roll it out in that network to all services, which is okay. The next architecture of the data center is coming up, so we can successfully run pilot services. Important things like our DNS servers or our web servers can already be enabled. Another thing that we saw is the CAM memory for the access lists is limited. The C6500 has room for exactly 128 bits, which is exactly enough for one IPv6 address, but not if you add ports, for example. And most of the time you want to have ports in your access list as well. So if you configure such an access list, that would get punted to the CPU, and having an access list in CPU is not a good idea. There's a workaround. You can enable access list compression, which actually saves 16-bit out of the interface ID address part of the IPv6 address and takes that for ports. There's additional knobs for fragments and IPsec, but you have to be just very careful with additional options so that the access list is not punted to the CPU. Something to be aware of. You can engineer around it. On the load balancer, we have a bug with neighbor discovery. So when a neighbor expires and is relearned, it's relearned on the wrong VLAN. So I think ARP used to be the most difficult protocol to implement in the IPv4 world, it seems to me, and now neighbor discovery has similar issues in IP version 6. So this is an open bug. There's a workaround. We can just configure a static entry for that. We can make do, but I'd like to have it solved. High-level address concept. How do we address those networks? Basically, we have one big chunk of IPv6 addresses /32 actually for our infrastructure. We divide that in two. The lower half is used for internet routable addresses. Those can be reached from the internet. And the upper half is used for internal networks. Those are filtered. We don't advertise them in BGP to the internet. And these are kind of our ULAs. Why don't we use unique local addresses? So this is the equivalent of private addressing in IPv6. The main reason is that ULA addresses will eventually leak to the internet, for example, in a trace route, and having internal addresses leaking out to the internet is not a nice thing to do. Then out of that block, we assign /48s per service or per zone. Whatever network wants to implement IPv6 can ask for some space out of that block, and it'll always get assigned one /48 that is internet routable and another /48 that is not routed to the internet. So this makes it very easy to create filters. Then in the data center itself, every service within the data center gets a /48 as well from the routed and or the non-routed range. And within every service we have, from every service we have 4,000/64 networks, which should be enough, basically. And then finally, and I'll conclude with that slide here, the actual addressing for the local network. We have two routers that each have a virtual, that have a physical address and a virtual address. Colon 1 is your virtual address. Colon 2 up to colon F would be the physical address. Then we have a range reserved for load balancers. And then we have a range reserved, which you see on the right-hand side, for VIP constructs of the load balancer. So the actual web servers that are accessible from the outside have physical addresses, and they have virtual addresses that are the load balanced addresses. And there's just a concept that is easy to reproduce and easy to read. We had the goal to have addresses that are human readable. We don't want to have those long IPv6 addresses nobody can remember. So I think we have found something that is easy to work with and minimizes human error in this sense. Okay.
All right.
Thank you very much.
Thank you very much, Martin.